learners, welcome to the another session of Environmental and Occupational Hazards MEV 002, that is the physical hazards. Today we are going to discuss about radiation and ionizing, that is the ionizing and also the non-ionizing radiation. So before going into the details of this session, first we have to acquaint with some of the words or some of the elements which we are going to come across. That is the first one I would like to introduce you is that ion. So that means what is meant by the ion? So any atom that has very little or more electrons than it has protons, that causes to have an electrical charge, and therefore it will be a chemically reactive. So that sort of any particle, normally we can call it as an ion. And also the next word I would like to introduce, the phenomenon, is ionization. So ionization is the process of adding one or more electrons to or removing one or more electronics from atoms or molecules, so thereby creating ions, free ions. So high temperatures, electrical discharges, or sometimes nuclear radiation that can cause the ionization. And then what is meant by the ionizing radiation? So that means ionization separately we have seen, ion we have separately seen. Now we are considering the ionization radiation. So ionization radiation is a radiation that is capable of displacing or removing or rearranging electrons from atoms, thereby producing ions. So high doses of ionizing radiation definitely produce severe skin or tissue damage. And next we will understand that radiation. So energy that is moving in the form of particles or waves which are familiar to the non-ionizing radiations like heat, light, and then radio waves and microwaves and ionizing radiation, which is a very high energy form of electromagnetic radiation and particles. So radiation is significantly used in many fields, in many operations also, that is food preparation, medicines, and the military, and power generation, and also in industries. So many radioactive events which are experienced by the general public, like nuclear weapon detonations over the Hiroshima and then Nagasaki during World War II. And in 1979 there, and then 3 Mile Island accidents in 1986. And we have seen that Chernobyl accident, and also in 2011 that is a tsunami impacted that Fukushima reactor. A general fear of radioactivity and radiation that exists in the human community because of the inadequate knowledge about the radiation. Just we will see that the consequences of the radioactive hazards or the radiation hazards. So obviously all human beings will scared about this type of hazards. And the most important is what is meant by the scope of the problem. How can we define the scope of this radiation hazard? So it is very difficult to estimate the extent of damage from the workplace exposure to the radiation at low level. And the adverse effect of the radiation that is caused by the chronic exposures, which are obviously dose related, and the cumulative effects and long latency periods of many years before coming that illness or the injury is observed. So what is meant by exact definition of the radiation? So that means it is nothing but an emission of high energy as electromagnetic wave, either in the form of particle or in the form of wave that is traveling through space. So it is an emission. So the radiation is two types. One is ionizing radiation and the second one is the non-ionizing radiation. So in the process of ionization, a stable atom or a molecule that loses or gains an electron. So that means by acquiring an electric charge. So any atom or molecule with an electric charge is known as the ion, just what we have seen earlier of this session. So ion has different chemical electrical properties, obviously because it has charge, and also change the release of energy than the present atom or the molecule. So this change in the properties that will definitely leads to the changes in the structure or the behavior of the cells in the human body. So ionizing radiation, that is consisting of energetic subatomic particles, ions or atoms, and that will propagate at high speeds. So and the electromagnetic waves, that is propagating through space and time, that are having the electromagnetic radiant energy. So the electromagnetic waves in the electromagnetic spectrum, that shows different frequencies which ranges from the below 1 hertz to above 1025 hertz. So these ranges are divided into discrete bands which having the different names like the radio waves, microwaves, infrared, visible and ultraviolet waves, and are also at the low frequency, that is a longer wavelength end of the spectrum, whereas the portion of the UV radiation. Along with these X-rays and gamma rays at also at the high frequency, that is a short wavelength. And then gamma rays, X-rays and also higher ultraviolet radiation, that is normally we can call it as an UV radiation, which are the part of electromagnetic spectrum, are ionizing. So the lower ultraviolet part of the electromagnetic spectrum and all the spectrum below UV, like including that visible light, infrared and microwave and radio waves, they are considered as a non-ionizing radiation because they are not ionizing. So the ionizing radiation, that is consists of the alpha particles, beta particles, neutrons and gamma rays and X-rays. So now we will see that what is the significance and the specification of the alpha radiation. So alpha radiation, generally it originates from the decay of the or the destruction of the heavy atoms like uranium and then radon. So this radiation is generated in the form of particles when an atom ejects 2 protons and 2 neutrons from its nucleus. So alpha radiation, that cannot pass through the skin, but it can be inhaled, swallowed, or it can enter the body through a cut or from the injured area. So this is a specification of that alpha particle. So after entering, it can cause the tissue damage that leads to sometimes cancer. So that's why those who are working in the radiation sector, they are prone to have these cancers. And then now second particle is the beta radiation. That is a beta particles that have negative charge and also smaller than the alpha particle with high energy. And the beta radiation is emitted by the unstable atoms like tritium and also carbon 14. And then unlike alpha radiation, they can continuously penetrate into the human tissue. So that is a most important characteristic feature of the beta particles. Next we will see that gamma and then X-rays. So gamma and X-ray radiation, they have the packets of pure energy. Normally we can consider them as a photons. So packets of energy. So gamma rays which are formed inside the atoms of elements like cobalt 60 or radium 266 with high energy waves that can penetrate the entire body. So they have a potential to alter the tissue and also the DNA. Whereas the X-rays, if you will consider, they have low energy with less penetrating capacity than the gamma rays. So they are widely used in the medical diagnostic testing. So everyone must have experienced that X-rays. So that is why doctor also will not prescribe repeatedly the X-rays. If it is necessary, then only they have to go for the X-rays. But one computed tomography, that is CT scan, that emits a much larger amount of radiation at about as much radiation as 200. That is normally we can observe that in the chest X-rays. So now we will see that the radiation of these health impacts, how this will occur. So first we will consider the ionizing radiation. Once the ionizing radiation that interacts with any matter, some amount of energy from the radiation is transferred to the affected matter. And then there are two types of energy transfers are there. One is the linear energy transfer, normally we can call it as LET, and also it is a measure of an average energy loss along the path of radiation. And second type of radiation is that is a high LET radiation like alpha particles that delivers a dose of radiation much more effectively than low LET radiations like X-ray or the gamma rays. once it interacts with the living tissues. The ionizing radiation that induce free radicals like hydroxide ions. Free radicals is that is a single electron. So, they are very active species. Once free radicals are formed, they can move rapidly within the body and also produce chemical changes in the molecules at the cellular level, and also they have the capacity to alter the DNA within the cell. So, some organs in the body which are very sensitive to radiation and induced injury than the others. So, it is very important and also necessary to consider the targeted organs of calculating the radiation dose by tissue weighing factors. For example, lung tissue if we will consider, and sometimes if it is a bone marrow, that they are considered more radio sensitive than skin and have a tissue weighing factor of 12 times, which is applicable to skin exposure. This is an important medical application and dose estimation when internal exposures like inhalation of radioactive dust which are released in mining industry or fail to handle the damage that is caused by the radiation, or sometimes the free radicals, the cell tissue will be mutated or sometimes die. So, these mutated cells have a little probability to turn into cancer and also passed on to the future generations if the reproductive organs are affected. So, accidental exposure to a high dose of radiation for a short period of time is known as an acute exposure and is able to produce biological effects after exposure. So, these health effects like nausea and then vomiting, and sometimes there is a fatigue and increased temperatures, blood changes, bone marrow damage, and also sometimes that is a damage to cell linings of the smaller intestines and damage to blood vessels in the brain. So, the delayed effects of the acute exposure that are various forms of cancers like leukemia, bone cancer, thyroid cancer, and also lung cancer and genetic defects. So, now we have to see that radiation dose and then dose limits, and then how they are and then how they have to be. So, the International Commission on Radiological Protection ICRP and other international organizations, they have absorbed dose is defined as a measure of the amount of radiation that a material has received and absorbed per unit mass, that is gray. So, that is represented as GY. So, gray is the unit of the absorbed dose. So, 1 gray is an energy deposition of 1 joules per kg. So, what are the risk assessments for the radiation exposure? So, according to the linear no threshold hypothesis, any risk assessment for the exposure to the radiation is based on the postulates that any amount of radiation exposure that can increase the chance of adverse biological effects like cancer. And the control of radiation protection is categorized again by the occupational radiation protection for the protection of workers, and medical radiation protection for the protection of patients and the radiographer, those who are taking it, and also public radiation protection for the protection of individual members in the population. So, now we will see the control of the exposure. So, the control of the exposure mainly is, number one is time, that is a duration. So, the amount of radiation exposure increases and decreases with the people spending time at or the near the source of radiation. So, minimize the time of exposure for the minimize the damage. And next comes to the distance. So, the more is the distance from the radiation sources, the less is the exposure. And if the distance is double, we can reduce the exposure by a factor of 4. And the third factor is the shielding. The source of ionizing radiation is reduced when it passes through the matter. So, shielding is the phenomenon where an absorber is placed between the matter and the source of radiation. An absorber can be any material like wooden boards, sometimes it may be a vehicle, sometimes it may be a heap of gravel, water, and also lead. So, this will increase in the shielding above the radiation sources and the decreasing the exposure. So, the shielding is also required to protect in different for the different energy radiations. For example, alpha particles if we will consider, very thin materials like paper, film 1.2 inches of air or 0.008 inches of water, that provides enough shielding because alpha particles cannot penetrate. If you will see the beta particle radiation, heavy or opaque covering like 10 feet of air or 2 inches of water is required to protect against the beta particles, because beta particles are able to penetrate and damage the skin. If you will go for the gamma particles, they are thick, dense shielding like 1.3 feet of lead or 6 feet of concrete or 13.8 feet of water is highly required to protect against the gamma rays. So, the higher the energy of gamma ray, the thicker the lead must be, 100%. We have to check. And then non-ionizing radiation, if we will consider any type of electromagnetic radiation that does not have enough energy per quantum to ionize atoms or molecules, but they are able to produce charged ions when passing through matter. So, this is a significance. So, they have sufficient energy for excitation, which is the movement of an electron to higher energy state, and it is also consists of radio waves, microwaves, infrared, visible and ultraviolet light. All technical devices which act as a source of non-ionizing radiation in the electromagnetic spectrum of frequencies ranging from 100 nanometers to the static fields. So, non-ionizing radiation relatively less hazardous to human than the ionizing radiation, because ionizing radiation has a wavelength less than 100 nanometers, or we can consider as a photon energy that is greater than 12.4 electron volts. However, depending on the frequency and the irradiance value, some sources of non-ionizing radiation can cause the human health hazard. So, now we will consider the health hazards of the ultraviolet radiation. So, the UV radiation has both positive and negative effects on human health. For example, they are used for killing bacteria in medical or dental applications they are using, and also sometimes they are used in the curing the resins. So, exposure to sunlight, we will get the UVB radiation that provides vitamin D, which is useful and which is required for the healthy bones. And acute exposure to UV radiation that can causes the sunburn and also arc eye, that is having a sensation of sand in the eye, irritating sensation. If you will see the chronic exposure results in skin cancers as well as the damage the eye lens and also cataracts. So, there is a risk of infectious disease and reduced efficiency of vaccinations also. And some other adverse health effects also we can observe in the UV bands like UVA. UVA definitely causes the suntan and the pigmentation. UVB is a skin erythema and then keratitis and also cataracts. If you will see the UVC radiation, that is a skin cancers and photosensitized products, either natural or synthetic chemicals, or sometimes coal tar and products and drugs like ibuprofen, and that increases the sensitivity of skin to UV radiation. And most of the UVC radiation that is filtered by the ozone layer, that is a plus point for us, and also both UVA and UVB that causes the melanoma and non-melanomic skin cancers. Some industries with highest percentage of workers, they are exposed to the sunlight like agriculture and then forestry, fishing. 75% are observed with the skin cancers. And also the construction, they have the 60% were reported for the cancers. So, according to the World Health Organization recommendations, use of sun protection devices like that glasses and shields, we can use that UV index reaches 3 or above to avoid adverse effects like skin damage and skin cancers. So, the effects of damage for unprotected skin exposure to sunlight during summer season between 10 am to 2 pm for approximately 10 minutes or the 12 minutes, that can cause mild sunburn for sunburn. For 30-minute exposure, we can experience the appreciable discomfort. That means we can experience that, we can realize. For about 60 minutes exposure, that can be resulted in the peeling as well as blistering, and for 2 hours exposure that results in the permanent skin damage. So these type of hazards we have to face. So now we will go for the controlling measures. So regular checkups for the UV radiation, that is emitted device like 400 volts mercury vapor lamps in the working environment, and switch on to the other alternative sources like sodium lamps. So in case of welding, the workers installation of the non-flammable screens as well as the partitions, and using of the signs to warn the welding areas, and using of the signs for the laser radiation, wearing personal protective equipment like filter shades for goggles, and also face shields to protect the eyes. Gloves should be worn to cover exposed skin. So these are some of the mitigation measures we can take care of. And what are the health hazards of the infrared radiation? According to ISO 20473, the infrared radiation spectrum, they have the following subbands like near infrared, that is 780 to 3000 nanometers. If it is a middle infrared radiation, that is 3000 to 50,000 nanometers. If it is the far infrared range, that is a 50,000 to 106 nanometers. So the main source of the IR radiation is the sun. But the other sources are also there that can emit the infrared radiation, are the some combustion process in furnaces and glass making, weldings, like that. So IR radiation is used significantly in heating lamps and also the black rooms, heaters, and also food processes like drying and then baking, heating and dehydrating the food products. So conveyor ovens are also used for curing and then preheating, drying, soldering, stress relieving, and also annealing that releases the IR radiation. So absorption of IR radiation, that is the infrared radiation, definitely leads to heat in the objects and also the human body, as well as the heat stress. So that means the consequence or the adverse effect of the IR radiation exposure is the heat stress. If you will go for the acute IR radiation exposure, that will definitely damages the cornea and also aqueous humor, and also damages the delicate photoreceptors permanently. So the effect of chronic exposure to the subbands of the IR, that is the MIR and FIR, it will causes the erythema, and MIR and the FIR, that is a pigmentation also, sometimes the photokeratosis, and also cataracts and retina burn with the NIR. And then what are the controlling measures for this type of radiation? So it can be done at the designing stage of the devices or the equipment, and to ensure by the engineering controls like shieldings and then fail-safe interlocks, which are also most important features we have to check before operating or before the designing stage. And high levels of IR radiation can be controlled by the PPEs, and like face shields or the glasses, protective clothing like aprons, and then gloves. If you will consider the health hazards of the visible radiation, they can also cause photoretinitis, that is also known as the blue light hazards, and also glare, sometimes it happens. So that is a gross overloading of the adaptation process of the eye. So that glaring is also two types. One is the absolute glare, when the source of light is very bright, that is which our eye cannot adapt to it immediately. And the other one is relative glare, that means there is an excessive brightness that contrasts between the various parts of the visual areas. So this create a visual fatigue that also adds to the general fatigue. And then visual fatigue normally resulted in the double vision and also painful irritation of the eye that reduces the powers of the accommodation, headache, and also reduced visual acuity. And we will see the controlling measures. For this one, there is a use of the natural light at maximum time, and wherever there is a possibility is there, and then workers have to access to window at their workplace, and they have to be provided the light breaks to the workers, that is a resting periods, and also daylight fluorescent tubes can be used wherever there is an artificial lighting is unavoidable. So these are the some of the mitigation measures we have to taken care of. So dear learner, we have to conclude this session that we have discussed some of the physical hazards. Basically a physical hazard is an agent and what type of factors and the circumstances that can cause harm with or without contact. And also they are categorized as types of occupational hazards and environmental hazards we have discussed. And some of the common source of physical hazards and also some of the sources of injuries in many industries that we have discussed. Extreme temperature, noise, vibration and also radiation hazards have been discussed. And these are considered fairly common workplace hazards. Naturally, noise is considered for the occupations like musicians, mining workers and construction workers, and they are exposed to more contact levels and then constantly for the noise for longer duration. So they are at a higher risk of hearing loss. And overexposure to extreme cold by workers, those who are working in outdoors in the winter season like fishermen, and those who are working in hydro and telecommunications, linemen and construction workers and transportation workers and military personnel and emergency response workers, and those who are working in the refrigerated warehouses are prone to illness like frostbite, frost nape and hyperthermia. And then lower working efficiency and impaired performance of the complex mental tasks, and are also reduced muscular strength and the stiff joint. So these are the some of the factors and then health ailments that we have discussed so far. Dear learner, you must have benefited with this session, and we will come up with the some other occupational and environmental hazards in the next session. Thank you.